Introduction to Networks, Monday. Week 3 already. Last class drop day was yesterday. Cyber defense coming up this weekend. Newman project. We're going to be working on setting up quite a few PCs for a lab, and I talked about master transcripts briefly. The concept here is, rather than transcripts with just grades, you actually build a transcript of the work you have done and things you have accomplished. Kind of like what they call electronic portfolio nowadays. Course items, we talked about packet tracer process. If that's not clear, you need to make sure you talk to me. Reviewed some terms and got started on protocols. We have rules, protocol suites, and standards we follow. Students worked on a lab and they made sure Wireshark was installed. Still working on basic configurations of a switch. First thing we did was we took a look at some communications things. The Iowa Communications Network. We talked a little bit about the internet and connecting in. So we have this connection to the internet. From here we have the main campus, and then we go to our firewall. And we have talked about firewalls before and how they restrict traffic. For example, in the DMZ we allow traffic into the DMZ. Only specific traffic, actually only going to work server number 2 internally. Okay, and we talked a little bit about network interface card connecting to a switch, and then we have a connection where we get information from Active Directory, right, to authenticate, to actually log in. Computer I'm on in the front, we identified it by an IP address. And then we talked a little bit about a URL. We have a domain name, use domain name services to get an IP. So we have a source where we're starting from, and then we have a destination where we're going, and we have a channel, the media that we send it across, which is either wire, wireless, or fiber optic. Pretty much. Now, how do we know? How does this communications work? You turn on the PC, you log in, it goes, it authenticates you, and then authorizes you to do something. You get a URL, I'll use a different color here, and you go out to the internet. The firewall keeps track of where you're going, and it lets that back in. All of that works because of some type of protocol. Protocols, we have a message, we encode the message, the data, format and encapsulate it. We have to put addresses on the message, right? We have to put a source and destination address. We need to categorize it in a certain size, and then timing. I mean, we've got to send and receive, and we have to know which we're doing when, and then how are we going to deliver. Are we going to make sure all of it gets there, or are we just going to send it and whatever gets there, whatever doesn't. All of these things are important in dealing with a protocol. Some type of rules that allow us to communicate. So we looked at an example in class. We took the switches from in class and we connected them all to a multi-layered switch, which allows us to be a switch and a router. That switch is connected to a router, which is connected to the DMZ, which now gives these people, when we put workstations on these switches, allows them to communicate out eventually to the internet. So in our configurations we were using Cisco, and Cisco for passwords. let's keep moving. Now, protocol suites, TCP/IP, and we have the OSI models. These are models that represent our communication flow. We have to control the flow of communications. So we start out with some data. It might be a URL, LinkedIn, so we have some application. And so we have the application layer that links us in to the data. So the data, let's say we have a browser up here, and we're going to send some data, a URL, we'll get to a website. The data then is passed down, it's presented, and we create a session. In the TCP/IP model, that whole thing is called application. We create this protocol data unit, and we split it into parts. Those would be segments. We have to split it into parts because we have to figure out how are we going to transport this. We're going to send them, but they have to be a certain size. Okay. Then we encapsulate. That encapsulation then moves here, and we encapsulate it again with something known as a packet. We put IP addresses on there. So we have the source and destination IPs to get it through the network. Then we move that down again, encapsulate it again with a frame. That's a data link. It links it from one location, one direct location, to another direct location. In framing, if we're using Ethernet, that would be a MAC address. And then the physical part figures out how to put the bits on the median. Is it wired, wireless, or fiber? How are the bits going to be represented on those mediums? The channel that moves the data. When the data gets to the other end, it goes backwards up until it hits the application. TCP/IP model of this, they call these whole first group the application layer. I'll use another color here. Application layer. The transport layer is still called the transport layer. The network layer is, they use the term internet layer, and then they combine this as network access. Okay. In the curriculum, we are on chapter 3, this whole idea of protocols and models. Okay, protocols, the rules for transmission, and the models are some way to visualize, to see the process for us humans. And you can imagine, for a computer, the rules have to be very specific because they can't assume anything. It has to be very specific. So we're going to finish up chapter 3. The next session will have an assessment, a short one, on chapters 1 and 2. And then next week we have a curriculum test over chapters 1 through 3, or modules 1 through 3. At the end of class on Monday. That's it.